Oh, hello and welcome to this episode for Electromaker. I'm your educator and host, Robin Mitchell. In today, ooh, ow, that's sharp. Ooh. Take two. This episode, we're going to be looking at the Zimablade single board computer so you can learn how to build your own x86 cluster to do servers and home labs so you can replace enterprise grade hardware like this nonsense and stop relying on the Pis. So let's see how we do it. So before we jump into the building of our x86 cluster using the Zimablade, I thought I would quickly mention and say that this video is focused on building the cluster, not actually running software like web servers and hosting and all that kind of jazz. That's going to be for another video because this is already going to get complicated as is. So as you can see over here, this is everything that Icewell sent to us, including extra RAM, all kinds of USB adapters, NVMe to PCIe adapters, 10 gigabit internet, which I'm really quite looking forward to trying, and some four-way network cards with 1 gigabit and stuff. So that's going to be very useful. And of course, we've got our three Zimablades right here, and they actually all came pre-installed with memory, which was very nice of them. But the stuff that you see over here was not provided by Icewell, but instead was provided by yours truly. Now, these are some old refurbished Seagate Barracuda drives. I don't care that they're different sizes. I'm just going to have one per Zimablade, so then we can... So everything that you see to my left here is everything that I've provided for this project, and you will need it too. So we've got ourselves the drive bays, which is actually not true because they did provide those and they provided the adapters as well. So I'm not quite sure why I put it over there. So we need to get ourselves the network switch. Now I bought this one off eBay for about 30 quid. It's a fanless one, it's quiet, it's silent, it's low power, it's great. It's got 24 ports and most importantly, it's managed. So we can actually create VLANs and stuff, which is really cool. It's a type 2. We've got ourselves 3 refurbished Barracuda drives. You can pick these up for 20 to 40 quid depending on the memory size. I picked these up from my local recycling centre and I got them for something like £10 per terabyte, which was an amazing steal. And then we've got our Cat 6 cables, which we're going to need for anything gigabit and above. And I'd also like to quickly mention and point out that the Zimaboard is also an absolutely fantastic product that they manufacture, Icewell. And personally, I actually use this for all my daily computing now. I've actually tried to go away from like typical desktop computers because this thing is low power, it's very capable, it's very small, and honestly I absolutely love using it. Plus because it's all solid state and stuff, you know, it's nice and fast. So yeah, which is why it's great. Now the reason why I'm also showing this was because initially with this project idea I was going to turn him into a pfSense router so he would control the internet across all these 3 devices in the cluster, but then I realized I actually kind of like it as a personal computer, so I decided against that. Instead I will just use the pfSense system that I've already built that works with my current server rack. Again, the managed switch is going to allow all of these 3 to communicate while keeping them isolated from the rest of my network. We've got our storage, and then we've got all our bits of peripherals. So without further ado, let's get straight to building it. Well, before we do that, let's learn why cloud services suck. And then of course why rack computers suck, and then we can see why these things might be the solution for you in your next home lab project. So while I unbox everything that Icewell sent to me for this video, I thought I would talk a bit about why cloud services suck. So the interesting thing about cloud services is that they've been really useful for the past, say like 20 years, where people have been able to kind of do their own services online. They don't need all this complicated hardware to make it work. They can deploy it really quickly. They can scale and all that kind of stuff. So let's say, for example, you've got a website like Facebook or something like that, and then you want to say, I don't know, I need 20 million more users. You can probably just go to some data center and say, just scale my solution across this. So that's why cloud services have been quite popular. Now, for all the benefits that these cloud services provide, there are some drawbacks that they have, and that's what we're going to be solving in this video. So the first one that I can think of is the fact that when it comes to hardware, you don't have full access to the underlying hardware in those service providers. So for example, when we build our cluster, we're going to be having direct access to all the hardware, so we can use every little bit of CPU frequency, memory bit, and whatever else is attached to this device. We can use every little bit. Unfortunately, when you use a cloud service, you kind of have layers. In some cases, you'll have restrictions. In other cases, you might be lucky and have access to the whole server rack, but even then, you don't have physical access to the hardware, so you can't make changes as you need. So for example, with one of these computers, let's say I want a bit more memory, I can add a different memory stick or an external SATA drive, but if I was dealing with a server rack, I just don't have that kind of freedom. Now, another major concern is privacy. So simply put, imagine the kind of applications that we're running these days. So for example, large AI systems which gather people's data, learns from it and tries to make some service better as a result. Now, cloud services are great to deploy on, but the problem is who controls that data? Who's responsible for its safety and storage? The number of times I've seen services fail or have a hack or something means that when you put potentially sensitive data online on those services, it's potentially vulnerable to cyber attacks because you're relying on that data center having adequate protections. Now, you might sit there and think, oh, okay, a large modern data center will have all the protections it needs. Well, that's not really true because we see it in the news all the time. Someone's got hacked or something like that. So if you build your own server system, then one of the great things is that all that data is held locally where you can see it. So for example, I've got my AI machine I'm currently building here, we've got all our graphics cards, but what's important is that the data that this thing is running is local, so I have control over it. And so those kind of reasons alone already tell you why building your own little cluster could actually be extremely beneficial for you, whether you're doing AI personal data or whether you want to have full control of the hardware and have the absolute freedom to run whatever platform you want, which comes to another point, security. So one thing that I need to mention about security is that, again, not only are you dependent on the service provider to provide you with all the security tools that you need to protect your data, but then what hardware are they running and what could happen to that hardware that might have backdoors and stuff. So for example, there was a story a number of years ago where a server discovered that some of their hardware had some backdoor chips in, and basically that would allow some hacker across the world to access all the stuff that they had on the server as a backdoor. So even though it's a big server, it costs a lot of money, because you don't have access to the hardware and you can't audit it yourself, you truly don't know who's really in control of your data. So at this point, you might be wondering, why not just build your cluster using a Pi? And yes, you can build Pi clusters. Of course, here I've got way too many Pi A's, I think they are, or something like that, or maybe Pi B's, I'm not too sure. But clearly I've got too many. And you might be wondering, why not just use these? The problem with the Pi is that it's ARM based, and what that really means is you can't use some of the best operating systems for clusters. So personally, I use Proxmox, and Proxmox is great because it allows for virtualization. It runs on the bare metal, and it's what I think what you call a type 3 or type 2 hypervisor, basically meaning, or it could be a type 1, I'm not quite sure, I have to put the bit of text there to just sort of describe it. Basically, it's a bare metal hypervisor, and so it runs directly on the metal, and then when you run your virtual machines, it also runs alongside, so it gets full access to the CPU, full access to memory, so your virtual machines have very little overhead, about 5% depending. But if you run something like on an ARM core, there are no hypervisors that are efficient like Proxmox on these. And of course, Proxmox being open source and free, you know, it would have gone nicely with the Pi, but again, you know, because Pi is ARM, it can't run Proxmox. Oh, and on that note, these aren't actually open source either. So quite frankly, Pis are rubbish anyway. Not like the Zimablade, which itself, I believe, is open source. So what I can't wait to do is to get a whole bunch of these together to build our x86 cluster. So let's go over to the server rack and see why this is better than a large Dell enterprise solution. So it's pretty obvious that cloud services suck. So that leaves us with the question, what's the alternative solution? Well, the alternative is to build your own server at home. Now, what I've got here is a system I've been building over the past 6 months to handle everything from my business and my personal stuff, including file storage, website hosting, Plex server, etc., etc. Now, while this system has been really fun to build and proven itself immensely valuable, it also has quite a number of drawbacks. Now, the first drawback is, as you can hear, these things are loud. Now, right now I've only got 3 on, but I have a total of 6 or 7 different racks. So when they're all turned on, they're all working at full power, it gets so loud it sounds like a plane is basically taking off. So that means that trying to record videos and everything else just becomes too difficult. The second problem is with that kind of noise also comes power consumption, and that basically means that you get a massive electrical bill at the end of the month, which honestly absolutely sucks paying. And then that brings us onto the third problem. With such noise and power also means a huge amount of heat production. So in the garage here at winter, that's absolutely great. Heats up the garage, no problem. In the summer, gets a little bit too hot. So like I said, this looks great. It's incredibly redundant. I can pop drives out as I need, and that's great for an enterprise solution. But it's not exactly good for those looking to do something at home, whether it's to host your own files, have a small little IoT platform, or even host your own websites, because in reality, you don't need that much processing power. So for me, I've got AI systems running on these things. But like I said, if you're just doing some small stuff, then this is really overkill. The power consumption is too great, the noise is too much, and the heat production is ridiculous. So the question is, what's the solution? Well, that's where the Zimablade comes in. So we've all seen the Zimaboard computer or Zimaboard single board server, and that machine is really, really cool. It's got a lot of power, a lot of capability, and it does well as a file server or a Plex server or something like that. But when it comes to scaling and things like high availability, sometimes you don't need such a big old powerful computer and then have lots of them stacked up. Sometimes you might want something a bit smaller, and this is where the Zimablade comes in. Now, at the heart of this computer is an Intel 64-bit CPU, and the CPU that you get with your machine will depend on the time and date and the type of machine that you want. Basically, I think it's to do with availability issues. But regardless, you still get a decent, I think it's an Intel Atom processor or a mobile processor, but the point is, it's got more than enough bang for buck for doing server work, things like file sharing, website hosting, and all that kind of jazz. So that's the first thing that makes this machine really nice, because as we said before, it can run pretty much any operating system out there. So you could do Windows, you could do Linux, you could do Mac, whatever. Oh, I mean, you could try Mac, you'd have to do it as a Hackintosh, but the point is, because it's x86, it supports most software already out there. And more importantly, it supports Proxmox, which is a Type 1 hypervisor, which we need in our server system because that gives us a bare metal environment to run virtual machines, so we get really good performance. And it also means we can do some cool stuff like IOMMU passing, where basically you can pass hardware to a virtual machine directly without the hypervisor standing in the way. And that's pretty cool. But again, too much for this video, and we'll see why that is in a future episode. At the same time, we've got 1 gigabit Ethernet port. Now you might be thinking, well, we've only got the one. Well, consider the tiny size. The more you put on there means you'll have to sacrifice something else. And on the other side, what they've done is they've got 2 SATA ports with power. So you can have up to 2 external HDDs or SDDs or whatever you want. So you're going to have plenty of storage and fast access to that storage. On the front, we have a blue USB port, so I believe that's at least 3.1, and I can see it's got the extra contact, so you can get the full speed out of that, which is nice. We've also got a mini DP port for display, and we also have a Type-C connector. Now, a bit of warning about this. This is not your regular Type-C connector. This is not USB-C. What this is a 12 volt, basically a 12 volt barrel jack using a USB-C cable connector. So not only should you not plug normal USB cables into this thing, but you must be extremely careful with the power adapter that it comes with, because it only outputs 12 volts, which means if you connect that thing to your phone, it will explode. Now, another amazing feature of this machine that you don't get with other single board computers is the RAM is swappable. You can change it and upgrade it. Now, the way you upgrade this, you have to kind of like do some weird skiddly thing where you have to like skid up the dude, come on. So once you've got this shield taken off, you then go ahead and unscrew the plastic cover, and then from there you can replace the RAM module, and you could go up to 16 gigs of RAM. Now I've got the 8 gig version, but I can change it for 16 if I wanted to. And this machine also comes with a 32 gigabyte inbuilt NVMe, but you're not going to use it with Proxmox for a whole load of reasons. Oh, and one more thing about the power. This thing comes with a 36 watt USB-C power adapter at 12 volts. But the total power dissipation of this thing is about 6 watts. So even though you've got a really large sort of adapter for it, the power consumption of this is really, really small. So compared to my, I think something like 600 to 700 watts on my AI server alone when it's doing some work, and you compare to a 6 watts idle. And I know you're going to say, oh, but it's not doing AI. Yes, well, even when that thing's idle and doing nothing, it's still doing about 250 watts. So 6 watts at idle is incredible, but I actually think that's 6 watts when it's under load, so I'm not quite sure. The point is, the power consumption is tiny. So with that looked at, let's build our cluster. So as you can see here, we have our entire setup set up on 2 Ice Whale cardboard boxes, because why not? Plus I couldn't get it in frame. The entire setup consists of 3 different Zimablades, each one with 8 gigabytes of RAM. We also have a network switch which is connected to each one of those blades. Each blade has at least 1 hard drive. The end one here has 2, because I wanted to just kind of like play with some ideas in the future. And again, they're all 3.5 inch standard spinning rust discs. You know, the discs that spin, click, click, click. Anyway, point is, they've each got their own USB power adapter at the back as well, which comes with the machines. And then basically we have a power adapter at the back, which is kind of just like an extension cord, which is glued on the back, and then we plug each one in. And then we can go ahead and power the entire thing from one plug. I forgot what it was called, a plug. Anyway, so in order to get Proxmox onto these systems, we're going to need a USB-A memory stick, memory SD thingamajig, whatever you want to call it, I don't know, flash drive. We're going to basically flash this with the ISO, stick it in the back, boot it up, and then use it. Now I'm looking at these and they only have 1 USB-A slot. So we're going to have to definitely get a hub or an adapter so that we can use more, or we could plug into the side one of those USB extenders, so then we can plug one of these and a keyboard at the same time. And then we've also got our mini display port on the back here, so then we can connect to a display, so we can program each one at a time, and then we can go ahead and get this x86 cluster working. Now, one more thing to note is that when you do install Proxmox onto these, it's important that you make sure that this thing, your network switch, is connected to the internet, because these devices are going to want to try and get an IP address from your local system. Now, I do recommend that you make these things static IP, so you dictate their IP address, but it's not entirely important. As long as you know what their IP is, you'll be able to log in, configure it, connect them all up, cluster them, whatever. So, without much further ado, let's power this up and hear the clicking. Of course, you don't really want to do this until you've got all your drives ready, but you know what? Let's just see if it boots and hear the clicks. Put my mic right next to it. Oh, I can hear it. Oh, that's lovely. Nice. So, to start with getting Proxmox installed, we need to go ahead and put Proxmox onto this USB flash drive as an ISO. So, first thing we're going to go ahead and do is actually start recording this environment right here, minimize that. Now we're going to go ahead and find the Proxmox ISO, so we can just go ahead and go straight to Google, type in Proxmox ISO, hit that, go straight to the first link, which is the actual Proxmox website. And then you have different options. We're going to go for the VE 8.2. It's the latest one. Hit download. We're going to watch that baby download, and you can see I've already got it, so I'm going to go ahead and cancel that. So now that we've got our ISO downloaded, it's time to pop it onto the USB drive, and to do that we need some ISO to USB software. Now, I personally recommend Rufus because, especially if you're working on Windows, because it's free, it's tiny, you don't need to install anything, it downloads as a portable and it's very nice. So if you want to go ahead and grab that, just go to Google, type in Rufus ISO. You'll see the first link is Rufus. Scroll down and you've got different download options, and I'd recommend you do the portable one so you don't need to install any extra little bits and bobs. Now, for some reason my downloads folder is taking a long time. This laptop is on its way out. So we have to wait and wait. So once we've got Rufus, we can go ahead and insert our USB drive. We can go ahead and select the device. As you can hear, if I'm going to go ahead and turn this down because it's probably quite loud. No label. We select the ISO that we want to burn, which in this case is the Proxmox VE 8.2. Yes, starts. Do the business, that's right, install it. Now this is over USB 3 or USB 4, so it's going to be well quick. You can see the speed of that writing, so this is insane. And then once that's done, we need to go ahead and connect a USB hub to each one of these and individually install Proxmox. For the display, we're going to use a standard HDMI display. I believe I've got a HDMI display somewhere. I'm probably looking at one right now, so I'm just thinking, yes, we should be able to use that. We'll also need a keyboard as well, so we can select options. A mouse doesn't hurt, but I don't think it's entirely important. So now we've got the ISO done, it's time to insert that ISO into these machines individually. So that wasn't completely and utterly painful. Right, we've got our hardware to actually be able to program this thing. We've got our thing, which is going to go in here. And then all we have to do now is boot it up and hope that it turns on. Yes, I am out of breath. I've been running around like crazy. So now I need my power adapter, which is right here. I will get it. Oh, come on. There we go. Alrighty. Let's go ahead and turn it on. And hopefully those lights blink. Now, while it blinks, I'll just quickly mention that this network switch needs about a minute or two to boot because it has to kind of like see if it's configured yet. Now, you're going to see all these lights dancing around. Eventually they're going to stop. Oh, I had to connect to the internet. Oh, good spot. Let's do that now. We can see right there, we have the Proxmox boot menu. So let's go ahead and hit enter on this bad boy. We want it with the graphics, of course. So now that the installer has loaded, it's time to go through the different options. The first one is we're going to accept the license and not bother to read it because, hey, that's what licenses were for. Then we're going to select the drive we're going to install Proxmox to. Now, there's a really important thing to note about these Zimablades and Proxmox in general. They have an internal NVMe, and even if you try, you won't be able to install Proxmox onto them without messing around with some configuration. That's a good thing because you don't want to install it onto the NVMe because Proxmox does a lot of writing to log files, and that will wear out those NVMEs so fast. So it's better to install Proxmox directly to a spinning rust disk or a proper SSD. In this case, we've got spinning rust disks or standard HDDs. So we're going to select the HDD instead of the internal NVMe. So we're going to scroll down till we see that we've got our disks. Now this is the one with the 2 disks on, so we've got 2 options. So I'm just going to go ahead and pick the first one. Don't really care which one it is. Go next. Do the country, United Kingdom. Then we're going to do the password, and I'm going to do, guess what? Password. Confirm it. Password. And then for the email, normally you'd put your proper email in here because then you could get Proxmox to actually email you alerts when things go wrong. I don't really care in this example, so I'm just going to go e@gmail.com, and some poor chap is going to get 1 billion emails every time this thing sends an error message. The next thing we need to do is configure the host name. Now this has to be unique for each machine, and I'm going to go ZB1 for Zimablade 1 and then Zimablade 2 and Zimablade 3 dot Proxmox dot local. The next thing we need to look at is the IP address. Now in this case I can tell that it's been dynamically assigned an IP address, and I can tell that because I know how my IP numbers work. 192.168.1.1 is my default gateway, my router. 1111 is the DNS server which I personally configured. So this number here is going to be critical, the IP address that this Zimablade will have. You need to write that down for each one you do because you're going to have to log in through the browser, so remember that number. So we write it down, in this case 221, go next, click install, and then the disk is going to do its little clicky things, it's going to install, and once it's done, it will reboot. So if all goes well, Proxmox will install itself, reboot. You'll have to remove the USB drive, and if we look carefully here, when it reboots, it goes into a login screen and it actually shows the IP address and the port which we can access the browser from. So in this case, the IP address was 192.168.1.221, and we have the port which is 8006. So if we enter that into our browser, we'll be able to access the Proxmox system all from a remote machine, and then we can move on with each of the other machines so that we get 3 different Proxmox installations, and then we're going to cluster them. So now that we've got Proxmox installed onto each of these Zimablades, it's time to cluster them together. So the first thing we're going to do is to log into the first machine, and then we're going to do that via the browser. So the first thing I need to do is start recording, obviously, so you can see what I can see. we go to Chrome or whatever your favorite browser is, we enter the IP address of that first machine. Now that was 221, I believe. I did write it down. I believe it was 221, then the last one was 224. So 221, 223 and 224. So we go to 192.168.1.221 and then the port, which is 8006. Oh, your connection is not private, but you know what? It's okay because we can trust the device. Well, I'd hope we could trust it. Anyway, once we're in, we go ahead and log in, which is root, and the password that we set, password, whoopsie, I don't care. Right, now we've got our node, we are logged in and we can start to add operating systems and virtual machines and all that jazz. But first, let's set up the cluster. So we go to the cluster option and we go to create cluster and we're going to give it a name. So Zima cluster. And we go ahead and click create. So now we need the joining information. So we click the button join information and we can copy that information. So whenever we log into the other two, we can add that information there and it will automatically join. So let's see how that works. New tab, go to the IP address of the next one, which is 223.8006. We log in as always, advanced. Yes, we can trust this. We use the default username, root, password. Okay, no problems. So now that we're on the second Zimablade computer, we need to connect it to the first one. And to do that, we go to cluster, we go to join cluster, and we paste the information that we copied from the previous one. We have to enter the password for the first one, which was just password. Then we click join Zima cluster, and we'll see what happens. Now you can tell if it's working or not by going to the first machine. And if you go to the first machine, you can see that the ZB2 has already been added. And yep, it's gone green, so it's online. So now we are connected to both machines from only logging into one, and it's seeing both on a cluster. Now it's time to add the third one. So we're going to go and log into the third one, which I think was 224.8006 as always. Yep. Proceed, no problems there. Root, password. Remember, these would be different depending if you made them different, you know, which I would absolutely recommend you do. Yep. Go to cluster, join, enter the data, insert the default password, go back to the first one. ZB3 has now shown up. In a second, that's going to go green, online, blah, blah, blah. And then we have our cluster of all three machines combined. We can go ahead and close that window because we don't need it anymore. And if we now click the data center, we can see all three devices in our cluster, and we can go to summary to see the combined capabilities of all those machines. So we've got 12 CPUs, which I believe is 4 CPUs per machine. We've got 22.82 gigabytes, so that's about 81624 minus a little bit extra. And storage, about 3.5 terabytes of data spread across all three. Now you have to do some special Zeph file storage systems to try and combine them all. And again, we're not going to do that in this video. We're just going to show how these three can be put together in a cluster, which they now are. So at this point, we could add virtual machines. We can make them high availability. So if one machine fails, it can transfer the virtual machine to another one and then run it from there automatically. And if that one fails, try again and transfer. We could create all kinds of virtualized routers, and then so that way you can then turn these machines into your router and your file server and your web server and everything else at the same time, which is really useful. Again, we can, as we just said before, we can cluster the storage, so you can make redundant storage across all three drives. So you save a file to one, it saves to three, and that also means in theory you can access 3 drives at the same time for recording or recalling your information. So now we have our completed x86 cluster based on the Zimablade, and now we can get cracking with home lab stuff. So just to wrap up, as we've seen, cloud services are great for scaling and quick deployment, but when it comes to data privacy, not probably the best solution you could use. When it comes to building servers at home, such as home labs and server racks and old enterprise hardware, that's great, it looks cool, sounds awesome, except for the fact that it consumes a ton of power, generates a ton of heat, and also generates a ton of noise. And if you want to build a quiet cluster, you could use things like Raspberry Pis, but their ARM architecture makes them extremely limited. So not only can we use the Zimablade single board computer as an alternative to the Raspberry Pi, but it can be a better alternative because being x86, it can run things like Proxmox natively. We've got our external SATA, which means we can have all kinds of hard drives plugged into these things. We've got our external PCIe, which is phenomenal, so we can even connect graphics cards to this if we wanted to and maybe do some basic AI stuff. And then we've also got our gigabit Ethernet, we've got our USB port, which is great. We've got all these little peripherals which come together to make a really nice machine. And the best part of all, listen to that. Absolute silence. And the heat generated from this thing is nowhere near to what that machine over there is currently doing. So all in all, this setup can run your websites, run your file hosting, it can do things like IoT platforms, it could run Docker images, do your things like Plex servers, and much, much more. So if you like what we do here at Electromaker and want to show your support, then consider heading over to the Electromaker store where you can buy all these bits and bobs and more for your next crazy and wacky project. This is Robin Mitchell, the educator, signing off.